Okay, here we are. It's Monday. Oh my God, it's Monday. It's Monday here on ThinkTech, and that means Monday afternoon we do research in Manoa. And we have our staff, Zuri Bender and Sachi Slomov here, handling everything. Wave, where it is, wave. Okay, and we have our Likable Science host. That's Ethan Allen. He's the host of Likable Science on Friday, because we want to talk about science today. Welcome.
Welcome, Jay. Good to be here.
So anyway, we're calling this the study of, rather the science of studying science, because there is a science to studying science, and this was made known at our show just last Friday, one day ago, with John Rand, the STEM director at UH, and Kevin Kelly, the guy who runs EPSCoR at UH, which is a federally funded program that encourages research. And so, you know, we thought, Ethan and me, that we would discuss exactly what it is to study science these days, in school before you get to college, and in college, how you pick an area, and you know, where is science going as an industry and as an occupation in this country? What are the jobs out there, and you know, what is the funding, because the funding will determine the jobs, and so forth. And I guess one other element we want to talk about today is, what do people think about science in this country? And I remember one time, Bill Gates went on a, you know, I don't know, 100 colleges around the country trying to pitch people on studying computer science. And he was really upset with the dismal reaction that he was getting for jobs, really good jobs at Microsoft. And he wound up, you know, not finding enough people to fill the jobs. And that's when Microsoft started to go overseas. And if you know Microsoft, you know there's a lot of people that they hired overseas in Microsoft's the way it works. And so, you know, we've had problems with people appreciating science in this country. I mean, look what happened with climate change. Look what's happening with GMOs. Oh, look what happened, look, measles. You know, let's talk about that later. So, first question is, you are a scientist, Ethan. So what was the magic moment for you?
I don't know that there was any particular magic moment for me. I have just always, since my earliest childhood, been just deeply fascinated by living things and sort of why they work, how they work. One of my earliest memories is of standing there. I was probably 3 years old. I was on eye level with our great white Pyrenees dog, and I remember looking into her big, liquidy brown eyes and being very intrigued by these things and kept trying to poke my fingers into them, which she would eventually get tired of and push me down to the floor and go to sleep. But she was very patient with me. And I have that memory. I have playing with animals, watching animals from my earliest childhood was just something that always intrigued me. And I never had any doubt that's what I was gonna go do. I've not quite gone that path, but.
Okay, so, but there came a time now, later in your schooling, where you decided that the science courses, the ones you favored, that you liked better. How did that work? Was it a specific teacher?
There were certainly, I had some outstanding teachers. I also had some less than stellar ones.
They come in both flavors.
Exactly. I got frightened off of organic chemistry early on by having a teacher who mumbled to the board rather than talking to the class for the whole course. And that was rather disturbing. But I've just had some great teachers and worked for wonderful people and had good
Where'd you go to school?
I did my undergraduate work at one of the state University of New York at Binghamton, actually, there, and then did my graduate work at the University of Oregon in Eugene.
Oh, so, that's good school, good science school.
Yeah, had a wonderful time there.
Also good sports.
Well, so I'm fond of saying I spent 6 years there training fish.
So what's your specialty as a scientist?
I was really trained in, depending on who I'm talking to, systems biology or neuroscience. But I basically, as I said, I spent 6 years teaching fish to swim little mazes and watching their reactions to changing their colors of their targets.
And they do.
And they did very well. Training the fish was never the challenge, really.
Okay, so let's move to now. Let's move to you know, the discussion that we had with John Rand and Kevin Kelly on Friday, you and me. What did you take from that on whether this new structure that they are building at UH, you know, sort of the integration of the community colleges, you know, the pathway program, where you can study science at the community colleges, and then you can go back if you want. You can study it for years and years and become, committed, dedicated to science. Do you think that has legs? Where's that going to go?
I think the basic idea of it is really very powerful, actually. It gives more people a doorway into science, into studying science at higher levels. Science, it's very easy to sort of get cut out of science if you don't take math at appropriate levels earlier in your schooling. You get discouraged from taking science. And by sort of opening up the doors at the community college level and inviting people back into science, they can really, I think, gain a pool of talent into the field that it really needs.
Is math important as a common denominator for all of science?
Really, math,
how does that work?
Pretty much is. There is just so much quantitative data. You just have to know how to deal with it. You have to be able to be reasonably comfortable, at least, looking at masses of data, figuring out what it means, being able to look at it, make an estimate from it, think about how to manipulate it to make it tell a story. And that really doesn't matter, I mean, to some extent, whether you're a field biologist or a geologist studying canyons or, a rocket scientist. I mean, all these things have their own special mathematics. But again, it's why this whole STEM field, science, technology, engineering, and math, is now is sort of the big buzzword, because it points out that these things are deeply interrelated. The mathematics ultimately underlies the engineering, which drives the technology, which makes instruments that make science advance, and the advances of science then fuel further engineering and technology discoveries. And I mean, the whole thing just keeps wrapping around itself. So it's really wonderful, I think, that both of our guests on Friday were talking about STEM as a vibrant entity.
I remember we were doing a movie at the IFA once, the Institute for Astronomy, and there were a bunch of mathematicians there. So I interviewed the guy. My first question was, so you're a mathematician? And he said, isn't everyone?
There we go, all right.
It just blew me away. You don't meet that many in the street, actually. Okay, so if I take these courses at some point, I mean STEM courses, at some point I'm going to need to focus in on something if I'm going to be useful. It's not like law school, where you can go to law school and it helps you deal with the world. You know how to make a contract, I guess, or something. But if you go into science, you have to specialize at some point, right?
You do as you move on into higher and higher levels of science, certainly. One of my guests earlier here stayed as a lab tech, and she talked, I thought, very passionately and very articulately about being a technician supporting lab. And yes, she learned parts of it in a good deal of depth, but had never pursued the advanced degrees and made a fine career out of that. And there's lots of room in science for people who don't want to go that deeply.
As techs,
right?
Technicians,
technologists of various sorts. People who have
technicians. I'm thinking.
Yeah, sort of supportive roles in various ways, and they can do incredibly valuable things for science. They can be very valuable in training the other students who come behind them, even students pursuing much more advanced degrees, because these students aren't going to have time to learn, for instance, all the different technological methods that are maybe required. And so the technician can help them sort of focus in and say, here's the key thing you need to know about frozen section cytology. Here's the key thing you need to know about counting beta radiation, whatever the issue may be.
So you can stop after college with a smattering of science courses and get a job as a technician in some laboratory or some scientific organization.
Sure, and here in the Pacific, I mean, there's a huge opening for that kind of stuff in all the marine studies that happen here. There's huge needs for people to be out there gathering organisms, doing basic analyses, helping us learn about the state of our corals, the state of our coral reef communities, the plastic in the ocean, I mean, all these things.
So what's the difference between a person, who does that, who goes off a Bachelor of Science degree into the scientific community, and a person with a PhD who's written some, PhD thesis, or rather dissertation, and made an advance in the field? What's the difference in terms of what that person does all day?
Well, largely the person who's gotten their doctorate, or as we tend to say, who has learned more and more about less and less until they know everything there is to know about nothing at all.
You heard it here on ThinkTech.
That person, typically in an academic environment, ends up running a lab, and that means they're hiring technicians, they're sketching out experiments in sort of the broad sense. They are training graduate students in postdoctoral fellowships and maybe undergraduate students in their labs, helping them all develop their methods of learning. But usually they're not actually the ones getting their hands wet doing the experiments anymore. They're too busy writing grants, writing articles, writing reports.
They become managers. They're science managers, research managers.
Right, and very much in a way. And this is what this guest had said. She didn't want to do that. She saw what that was all about, and saw where her boss's times were spent, and didn't want to spend her time that way. And she preferred to stay in the lab, working in the lab every day.
So we had a guest here in that chair a couple of weeks ago who had been on one of our luncheon programs, Cecilia Shikuma was her name. And she talked about the same thing. She was an MD researcher.
Right.
Most of her time was in management,
right.
Writing grants, writing papers, supervising people, making sure all the assets were in place and that they were doing what they were supposed to do. But she wasn't doing it, she was supervising it.
Yes. Yes.
And I don't think people realize that. They think that everybody with a PhD has got a white coat and a test tube.
Absolutely.
Not really so.
Not true at all, right. Indeed, only typically in the earliest stages when you've just gotten your postdoctoral fellowships and you're a junior researcher of some sort, are you really, then day and night, yes, you're doing the science, whether it's in the lab or in the field, wherever it may be happening.
Do you take a course for that, like grant management or something?
Well, more and more they've actually recognized that, yeah, it does take some training. People should get some background in learning that kind of stuff because, yeah, reading the Federal Register is a task, and following all the rules and regulations of these granting agencies can
You've done that.
A bit
it's
of that.
It's a bear, isn't it?
Yes. Yeah,
and you don't always succeed. You can put in hundreds of hours writing these things and then have a flub.
The funding rates, particularly from the federal agencies, have been steadily dropping over my career. I mean, it used to be that they would fund 25, 30, 35% of the applications they'd receive. Many of these same programs now are funding less than 10%. So back 20, 30 years ago,
90% of the people who apply get zilch.
Yeah, exactly. And many years ago, yes, you could write 3, 4, 5 applications, and you began sort of just by the odd numbers would catch up with you. Now you can't do that. You have to write 10, 12, 14 applications, and these are huge, complex documents.
Well, is there a redundancy where you can write the same application and send them to 3 people?
Yeah, not so much. You have to be very careful about doing that kind of thing.
Because if they find out they're not happy with you.
Right, that's why I say you have to be very clear that, yes, it's okay to send this precisely the same application. Usually it isn't precisely the same one. You end up changing 1,000 details anyhow in each version to somebody else, even if you're pursuing the same general question.
Well, you don't want to write the same grant to 2 separate agencies and then get the grant to do the same work that you described in each one, because then you're getting double trouble.
Really what you want to do is get one cycle ahead on the whole thing, so you write the grants for the work that you've been doing, right? Because you know how that's going to come out, so your grants become very good at predicting what the response is going to be, what the results are going to be. And then you tend to get funding for that kind of positive science. But
it just occurred to me, Ethan,
it's very tricky to get ahead on it.
Yeah, I mean, it's hard, and you don't always succeed, and you spend all this time, and if you don't succeed, you've wasted the time. Your supervisor's not impressed if you don't get the money.
Right.
So there's one question, then we'll go to a break, and that is, are there classes, at UH or other schools, are there online programs where I can learn to write a grant, learn those fine points? Do you think maybe ThinkTech should have a class?
Now, that would be interesting. There's a great need, in a sense, for people to learn to write grants. People write rather poorly often, and grant writing is a particular form of sort of science fiction, as it were. It requires its own rules and regulations. But I don't know that I want more people learning how to do this. This is one of the things I do.
It's true. It's competitive. Just
more
you guys. We're not going to tell you too much about it. Okay, but we will. We'll tell you a lot about it. That's Ethan Allen. He's the host of Likable Science, and he's my guest today here on Research in Manoa. We're talking about the science of studying science, and there's plenty of science there. We'll be right back.
Hi, my name is Andrew Howard. I'm an astronomer at the Institute for Astronomy at the University of Hawaii up in Manoa. I'd like to tell you about the annual open house that we're having. This year it is on April 6th, 11 to 4 p.m. It's an all ages event, kids, grown-ups, even people in between. Everyone is welcome. We have a lot of really fun activities. You get to meet astronomers, look at yourself in an infrared camera, play with Legos, make robots, look at videos. You can even make some of the kids like to make comets out of gravel and snow. Even adults like to do that too. You'll be able to look at the sun with a solar camera safely. It's really a great activity. We do this every year in April, and I hope to see you this year. Thanks.
Okay, we're still here. We're back. We're here with Ethan Allen, who's the host of Likable Science on Fridays, 1 to 2.
Yes, indeed.
And today he's my guest, and we're talking about research in Manoa. We're talking about the science of studying science. Those formative years for those kids who are in the program that John Rand is developing with Kevin Kelly at the UH. And so, what is the magic moment for the kids in school? What advice would you give them for locking onto science as a specialty, as an educational pathway, and as a career?
Well, I think it's critical to have teachers who are somewhat familiar with science and understand at least the basics of science. Science is really, it is fun, it's intriguing, it's fascinating stuff, and to have teachers who at least have some of that gut feeling so they can help the kids see that science is not all about memorizing long lists of vocabulary and learning complex relationships among different things. Science is all about looking for patterns and seeing interesting things happening and discovering that if you do this, that happens, or if you do that, the other thing happens. So it's very related to the students' lives. And this is what this focus now on STEM, I think, is a powerful force for helping this. That is, science too often has been taught as these very discrete subjects. So there's geology on one hand, there's biology on the other hand, there's chemistry, there's physics. But really they all build on math, actually, fundamentally. And then physics sort of springs out of the mathematics, and chemistry, of course, it rests on the physics, and then biology comes out of the chemistry, and so they all really do.
But as we go forward, we get more specialized in as you said before.
You do.
You learn a lot about a little and lesser and lesson, then it's nothing.
Right. And one of the things we see in this day and age now is that a lot of the very happening science, the hot science, is happening at the interfaces of fields. So it's not strictly biology, it's not strictly chemistry. It's when you begin
New
to get,
fields altogether.
when you get biologists and chemists and engineers all like working together on a problem, that you get very interesting things happening, fascinating kinds
So
of.
here we are in the crucible of the high school class,
Right.
okay, that we're talking about, and trying to make this the best possible experience, or the community college class too. And the teacher there has probably got a degree, at least in high school, in education, he's gonna have that. But then he's got the technician level of science training. Maybe he has a BS, maybe, from a college. He has not been a scientist. He has not done research. He has not supervised, research or grant writing or anything. Never had a laboratory and all this, and he's the one teaching them. Is that adequate to instill in them, to inculcate that sense of excitement you're talking about? Don't we need more now in the 21st century?
I would tend to think so, yes. I believe you're quite right there, Jay, that we need particularly people who have that passion for science. Whether they've pursued it with a higher degree or not is less important, but people who really understand what science is, who have sort of been bitten by the science bug themselves, who are curious about why things happen, who will help their students understand when you knock over a cup of coffee and you see the way the coffee flows, there may be interesting questions in that pattern of the coffee stain that's there. And you can probably ask your students, and you could probably start studying the way this coffee flows and the way it's trickling out along the paper. You could probably make a dozen science lessons out of that. You could probably write a book about it if you really put your mind to it. So it's not whether I know anything about how flow works on a atomic level or molecular level. It's not really terribly important in that sense. If I can help others see that there's really interesting stuff going on there,
Well, my old story about Bob Olson, who created the New Fitzsimmons in Denver, which is a great big pharma collaboration incubator place, research center for big pharma. And he figured out how to bring the research in from everywhere. And it was food. He had a big brunch or something every few days for the scientists. And they would come around and talk to each other and give speeches to each other and share their stuff. They were teaching. That's what they were really doing. They weren't worried about intellectual property or anything like that.
All right.
Just wanted to tell a peer who was willing to listen what they were doing. Because I think you get very isolated if you're in that very small, silo of what you're doing.
Yes, it's very
and
easy.
it really helps you to talk to somebody else. And therefore, if you're a teacher, I can imagine, I see the excitement in you. If you're a teacher or a teller, a lecturer or whatever, telling people who don't necessarily know what you're doing, then you get very excited and they benefit too. And in fact, science benefits by that conversation.
Exactly.
So we need teachers who are like that.
Yes, we absolutely do. And they need to be supported by good materials, not 10-year-old textbooks, particularly out here in the tropics. We see a lot of mainland textbooks that talk about continental ecosystems, for example, that mean nothing to the students here. They don't care about the snowshoe hare and the lynx and the snowpack.
Got to make it relevant.
Right. You got to. So that's one of the things we try to do is help bring relevant science into students' lives. And my own Water for Life project is trying to do this out in...
This is for Pacific Resources Education and Learning.
Right, exactly. It's an NSF grant that I have with them. It takes me out to the Marshall Islands, Chuuk and Yap states in Micronesia, and Palau, and I was just out there. And we're getting communities engaged in looking at the ideas behind drinking water and how do they build resiliency in terms of their water sources.
It's not just kids then.
No, it's whole communities, right?
You're telling them science is what you're
Well,
telling
I'm hopefully stimulating them to learn science, yes. So we talk with them about it, and there's very interesting things I just found out on my trip. I was just out there about how lots of people there don't really trust their municipal water systems, even if they have them. And in some cases, that's well-founded. There are some that don't produce very good quality water. But even the ones that do, and produce fine, perfectly drinkable tap water, a lot of people would still prefer to drink rainwater, even if it's less...
Was it cultural?
There's a cultural aspect to it, yeah. There's a belief that chlorine may not be good for you in some way. If the chlorinated water is bad. There's a taste issue.
Would you argue with them about it?
Well,
would you say you guys are really not getting the picture? Or would you say it's okay?
No, we had actually, I was there with my evaluator, and we had a number of discussions about this, and I thought the key thing is to help people know their water. You've got to know what your water is to know if it's drinkable, basically. And because on a lot of the outer islands, they don't have the option of any municipal water, and they must rely on rainwater. So they should learn how to catch it, how to store it properly, how to be sure it stays clean, and how to decontaminate it if necessary. Very meaningful science. This is literally a matter of life and death for these people
There's a gratification, there's a psychic benefit involved in that. It's one thing to do organic chemistry and mumble into the blackboard, as you mentioned. Or for that matter, take a MOOCs course, should be very, super sophisticated MOOCs course about a subject you don't care. It'd be the same thing as mumbling into the blackboard. But if you have it right in front of you, if it affects your life, touches your community, then you're going to learn that science.
Exactly. These communities are regularly beset by waterborne diseases of various sorts, or the specter of drought hangs over them when it stops raining. Yes, they have vested interests in sort of every person in learning a little more about water, learning how to conserve it, how to take care of it. So yeah, it's in a sense my task is much easier for me there, but I think it's a nice example of sort of the whole STEM business. Yes, we work with people not just on water, but on the technologies, albeit simple technologies of capturing and storing water, how you have to get your roof set up, how you have to get your roof clean, setting up guttering, proper guttering. I mean, it's engineering issues, right? How do you make a gutter flow the way you want it to flow?
They got the perfect guy, because you can do all of that. Really, I mean, and who else is around to help them?
There's a lot of talent out there, and that's one of the issues is developing the innate interests and talents that are in these more remote island spots when there aren't a lot of people with advanced degrees at all out there, and their schools are, their whole workforce is undertrained itself. So how do we help them study science in sort of scientifically good ways?
So do you encourage them to come back to, say, Hawaii or elsewhere and take science as a college or graduate course?
Sure. I mean, our aim is basically to have every student get through their local K-12 school system with that kind of option, that they're interested enough, vibrant enough, good enough student that they could come here to Hawaii or go to a West Coast school or whatever and study science if they wanted to do that. Or that they could stay on their island and fish or farm, you know, in probably a better way maybe than their parents did, in a more productive way now, a way that's taking into account the changes in the water and the air, the rainfall patterns that we're seeing, you know.
This goes, though, to the phenomenon that we see here in Hawaii, where the scientists come to the environment. I'm sure there are scientists here that have grown up in Hawaii and, you know, are fully aware of the earth and the earth and the sky and the ocean and whatnot. But there are a lot of people who have studied that elsewhere and who have come here because this is the place for it.
Right.
If you want to do marine biology, this is the place for it.
Right.
And so we are effectively taking them away from where they were before. Mm-hmm. You have to travel to the scientific environment that is your specialty. You must do that.
Right. The telescopes on the Big Island are not going to live anywhere else.
Yeah.
They've got
So science has its own locations.
Absolutely.
And you are, I mean, I hate to put it this way, you're a slave to those locations.
Well, it's place-based learning we talk about.
Okay, that's a much better way to put it.
But yes, I mean, right. If you're living in the middle of the Gobi Desert, the coral reef ecology probably isn't going to be very interesting to you.
Yeah.
Just as, yes, sitting here on an island, we don't particularly care about, you know, Saharan sand dunes and how and why they're moving, you know.
So suppose I go through this, I get very interested. I take a BS in science in college. I go for graduate work. I work in a laboratory as a technician, you know, for my spending money. I take a master's. I take a PhD. There are a lot of programs that don't have masters anymore. They go straight to the PhD.
Right.
So it's interesting how that works. That wasn't in my day. It wasn't in your day either.
Well, actually, I never got a master's.
Are you a product of that?
Yeah.
You don't have a master's?
No, I went straight from a bachelor's.
Okay, security.
I worked for a few years as a technician until I knew I wanted really to go back.
You don't need a master's.
Right. No, I just went through, and I think there was an option in that program. If you sort of copped out at some point, you could probably walk away with a master's, but it really wasn't.
Yeah.
It wasn't what it was set up to do.
So now you have your PhD. What kind of, if you get a job with industry, I expect you'll be well paid. Mm-hmm. Well, maybe Prell is industry in this sense.
Prell is a nonprofit.
Nonprofit, okay. If you get a job with a nonprofit, that's a different kettle of fish. Mm-hmm. If you get a job with academia, that's more like a nonprofit.
Right.
You don't make that much money, am I right? So what do people do this for? I mean, is it for the gratification? Is it for advancing humankind? What is the reason they do it?
I think most good scientists do science because they can't do anything else, really, that they're driven by their very sort of deep in their psyche to discover these things, to learn about them, to look at this stuff, to take it apart, to try to understand what makes it tick. They wouldn't be happy sitting there in an accounting firm, you know, adding up columns and numbers all day, or, you know, working in a manufacturing plant putting together a better car.
Does that ever happen? I wonder if that happens. You know, here I have a PhD in, I don't know, marine biology. Okay, and one day I say, I had enough of this. I'm not doing this anymore. I'm going to go Wall Street, and I'm going to be a stockbroker. Mm-hmm. I'm going to take my PhD with me, which I'm a smart guy. I could do a PhD. It's not easy. And I go to Wall Street, and I become a stockbroker. I never think of marine biology ever again in my life. Does this ever happen?
Pretty rarely, I think. Even when you go out of your field of training, and indeed I was trained as a neuroscientist, really, but I've not really done neuroscience, particularly in quite a number of years. But you bring a lot of the skills and the talents that you learn, the capacity to think about things in an organized way, to construct a rational argument based on data and evidence. You bring these to whatever you're doing, whether it's teaching or lawyering or, you know, whatever you may be pursuing. There are a few people who, you know, we have a few scientists among our political leaders.
An engineer was the
right
governor of the state.
Right, there we go. So, you know, it does happen. It's not unheard of, certainly.
No. I just wonder, are there enough jobs out there, too? If I take my marine biology, it doesn't have to be that, but anything. I have a PhD in a very focused area, which makes me really an expert, and I wrote a good dissertation in this. Are there jobs for me? outside of academia? Well, I'll ask you both ways.
Right,
Both.
and that's the thing. I think a lot of emerging scientists have to be a little more creative now than they used to. It used to be, yes, pretty much large segments of the graduating doctorates went into academia. The ranks are pretty full there. Universities have been in tight times. They haven't been creating new positions. So there's sort of this bottleneck now and this backlog, and lots more people are taking 2, 3, 4 postdoctoral fellowships, sort of biding their time, trying to figure out what to do. And lots of them are leaving and taking industry jobs or government jobs in EPA or NOAA or working for a nonprofit.
But this is not exactly what they had in mind.
No, for lots
They want
of,
to be a research scientist.
right, and so, in some of those you can still do that. You know, you can be an EPA research scientist. You're probably maybe more mission driven than perhaps was your initial thinking.
Yeah,
But
yeah.
in other cases, yeah, you have to give up that idea of doing research. But lots of people find that sharing their science with the public is very satisfying. That's being able to talk to people about it as part of their work is a good thing. Or to pull together other people's work and synthesize science, or to make policy about science. These are all options. But yeah, it's certainly, it's not the rosiest of pictures, not the best of time for science.
That's because of the grants.
Yes.
There's not as much grant money out there.
Right, the grant money has leveled off, and
The research
there are more
jobs
people.
depend on grants.
Right, so it's more competitive, and yeah, the universities themselves can't as freely supported as they used to. So yeah, there's a
So
lot
if
more
I meet a
attention everywhere.
scientist who has a job, I should be impressed.
Absolutely, absolutely.
And that's Ethan Allen. He has a job. He's the host of Likable Science, among other things. And this is research in Manoa, and we're talking about the science of studying science. I'm going to take a short break. We'll be right back. I'm going to discuss the public opinion about science, which is really uncomfortable for me.
Okay.
Aloha, my name is Paul Jackson, better known as PJ, and my local interest is in sports. I have my own sports radio show at KWAI AM 1080 that you can stream live. I also have my own website, pjsportsradio.com. We have live guests in studio, and we talk about discussions and topics that everyone wants to know locally here on the islands. We cover everything from surfing to basketball to whatever's going on locally, sports-wise. We try to do our best and cover the topics in depth as much as we can. Once again, thank you for joining PJ here on Hawaii Sports Update. Mahalo.
Okay, we're back. We're live. We're here with Ethan Allen. We're getting into the good stuff now. He's the host of Likable Science on Friday, 1 to 2. And he's my guest today here on Research in Manoa. And we're talking about the science of studying science. But one of the things we have to talk about is all this odd expression in the media and by people's behavior that they don't trust science. I'm talking about people who didn't want to use chlorination in the water. And I think you mentioned in Indonesia a similar issue. And then, of course, we have the measles. People don't want to be vaccinated. We have the ongoing, believe it or not, the ongoing issue about climate change. Unbelievable. And we have this really strange argument about GMOs. I mean, we have an anti-science community on a local level, a national level, and an international level. Was this the case before when you went to school? I don't remember it, but it's certainly the case now. Are we going backward like a mile a minute? What's going on?
I think the public may be a little more cynical than they used to be, and that to some extent has had impacts on science as an enterprise. For years, people have not understood science. For years and years, there's been a great activity that they do with small children. They have what's called Draw a Scientist activities. So they just ask kids to get a piece of paper and a pencil and draw what you think a scientist is. And for years, as long as they've been doing this, they're drawing white lab coats, stuff in the pocket, wild hair, big glasses usually. I mean, it's really the very stereotypical kinds of images of what a scientist really is. Nowadays, you're seeing a little better that there is actually some recognition of diverse you know, women can be scientists, and not all scientists wear lab coats. People of color are scientists.
You got to be careful because the hairdressers also wear white coats. Can't get that confused.
There we go.
Technicians at every level wear white coats.
But it is, depending upon whose measure of scientifically literate populations you talk about, we have a disturbingly small percentage of our population is scientifically literate. People who come out of our best schools lack very core science information. There was a classic set of videos done years ago called A Private Universe, thinking about people's minds as being their private universe. The first of these videos they went to Harvard at graduation and videotaped Harvard graduates, and they would go up to the Harvard graduate and say, "So, do you know why it's warmer in the summer and colder in the winter?" And the Harvard graduate in their cap and gown would smile and say, "Oh, sure." They say, "Well, tell us." And people would say, "Oh, it's because the Earth is closer to the sun in the summer and further away in the winter," which of course is dead wrong. And because it has to do with the tilt of the Earth's axis and the hemispheres and all this. But so
We're going to have him explain the answer to that in a minute. Go ahead.
surprisingly large numbers of Harvard grads got that wrong. So the next year, just to be fair, they went to MIT. And they went to MIT's graduation and held out a flashlight bulb, a piece of wire, and a battery. And I asked them, "Can you make the bulb light?" And of course, all the MIT grads said yes. And then you watch on this video as they fumble and fumble. And one of them finally, and they can't do it. And one of them looks up and says, "Well, I'm a mechanical engineer, not an electrical engineer."
That's funny.
This really is. These things that you would have thought they would have gotten in 3rd grade or 5th grade or 8th grade, somewhere they would have picked up this really basic knowledge.
fundamental
You know, the
stuff.
seasons, that's not a very complicated thing. You know, that's a really pretty basic understanding of how the world works when you're living in the temperate zone.
That's very scary.
yeah.
This is not a matter of having gotten into the wrong or a specialty that didn't include that.
Right,
This
no.
is basic
Yeah.
course material.
Yeah, this is stuff that, how they ever got out of our, graduated from some of our very
You
best
get out of
schools.
Harvard and MIT.
Yeah,
That's
yeah.
a surprise.
So it's
What does this tell us now?
Well, what it tells us is it's then not surprising that we don't have a very high degree of scientific literacy, and therefore we are open to these things like the anti-vaccination campaigns, where one study with 12 subjects in it somehow became the basis for this whole campaign, saying, you know, the vaccinations cause autism, and, you know, which has been widely refuted. I mean, huge studies have been done nullifying that idea, and yet because it was a popular thing, it was hot and sexy. Oh, look at the big bad drug companies, you know, they're hurting us on the side, and you know, all for the sake of the almighty dollar. So that made it a sellable story. So it became a good story, and lots of people believed it, and lots of people still believe it. There's still lots of parents who won't vaccinate their kids, and doing their own kids and all the kids around them huge disservice, by the by. So it's really frightening to me that how easily people ignore evidence, basically.
It's really strange that you know, this is an activism of sorts, and we're talking as much about activism as we're talking about science. I remember a case of a guy who was trying to get a state permit to do aquaculture off Kona, and found that there was an organization out of Washington, D.C. that would oppose aquaculture, and their reasons, trust me, were not scientific, but semi-scientific. You know, it sounded like science, and it's an activist organization. And then you look at the filings of this organization in the IRS. They're public because it's nonprofit, and you find that they are collecting an enormous amount of money, and that their officers are paid a lot of money, more money than you would ever expect. And there's a lot of people drawing down big salaries in this particular activist company. You say, my goodness, this is driven by money. They have an anti-aquaculture position on things. They're trying to fight it everywhere in the world for their own strange reasons, non-scientific. And they are able to sell that idea to people who would write checks. Now, that's how they live. They are motivated to do that. They are motivated to sell to these guys to get the checks, and then they are, you know, required to go out and argue that position. And I mean, I use this one company as an example, but there are thousands and thousands of companies where they can't take the check. They can't get paid unless they take that position. And the people who are giving them the money may or may not fully understand, but they're giving them the money. It's a salesmanship issue on the one hand, and it's an advocacy issue on the other.
Absolutely.
And that's what I think has happened with a lot of issues where science has taken the hit.
Absolutely. And National Science Foundation is trying to help train scientists to sell their work a little better. They've put out a Messengers of Science training, and they had some session of it here, a 2-day, 3-day session a couple of years ago, helping scientists craft and learn to craft and frame the reason they're doing their work, what's exciting about their work, why people should support their work, these kind of sort of core issues. And yeah, when you're running into anti-science people, it's very hard to fight them. They often have, yes, large resources behind them. They've been well funded in many cases. And I mean,
but it's based on hokum
Yeah.
or religion, possibly.
Yeah.
In any event, bad thinking.
Yeah, I mean, you can argue uncontrolled agriculture is certainly a bad thing, and it's caused massive pollution in some areas and done no favor for wild fish populations in other places. But there's pluses, there's minuses, and it should be discussed rationally, and the evidence should be examined, just as with any other topic you choose to look at. GMOs, again, what is the evidence? And people make all sorts of strange claims in that field too, just as with climate.
I mean, there were congressmen and senators in Congress, I mean, presumably somewhat educated, who opposed any notion of climate change for years, maybe still.
Well, oh yeah, still. The real funny one is years ago when the Indiana state legislators got together and they decided that pi, the mathematical constant, should be made as 3.
Because easier.
Yeah. And I mean, it's
My
sort of
God,
wrong on
that's
so many
so
levels.
scary,
And they
that is so
actually
scary.
passed that as a
They
resolution.
passed a bill.
Yeah.
Pi will now henceforth be
Be
3.
3.
After that, they changed the law of physics in general, I suppose.
Right, I mean, it's wrong on so many levels, and the fact that we get debated like that just, again, it sort of shows the scientific illiteracy,
Well, I mean, I think it's in part, it's a failure of the scientific
Oh,
establishment.
absolutely.
They really can't afford to have these people out there fighting with them that way. You have to teach them.
Yeah.
And the example you gave is good. I mean, you have to build an organization that will go out and be a countervailing force to the other organization that I mentioned.
Right.
That's just doing hokum.
Right.
And this is scary because I think we're at the losing end of that. We're not doing enough of it. As a result, there are more issues like GMOs, like vaccinations for measles. Oh, that's a bad one. Like climate change in general. There are probably others in the same, the whole thing about chlorination too. The resistance to science is extraordinary. It's like this huge gap in public education.
It is.
It goes back to STEM, doesn't it?
It does, because science has been seen as this very separate entity. There is sort of the rest of the world and there is science, and the two never really meet. And by talking about STEM and helping kids from earliest times understand that what they're doing as they're building a structure is engineering, it's using technology, it's thinking mathematically, it's based on science principles, then the thinking is that the kids will be more engaged and be less susceptible to these sort of off-the-wall anti-science arguments.
It's very scary. I mean, and the same people who would oppose it are out there using their iPhones, relying on modern technology to beat the band.
Sure.
So I don't know what it is. It's for sort of selective or with a blind eye. And I don't know if it's enough to say, let's do STEM in the schools and build a generation of scientists, which we should do. But I think we also need to have people who will advocate for science.
Oh, absolutely.
Like right here, like you and me.
Absolutely. People need to, and it needs to be done within schools, but beyond schools too, in broad community settings, Yeah.
Well, okay. Frittering away another perfectly fine hour. As they used to say on Car Talk. With Ethan Allen, the host of Likable Science, and me, Jay Fidell, here on Research in Manoa, the study of, that it is the science of studying science. Now, there's more to come because there's a lot more here. And we have to follow it, in the granular, and we have to follow every inch of it.
Okay.
We have to have these conversations.
We'll do it.
Thank you, Ethan.
Thank you, Jay.
Aloha.
Aloha.